Here's the example. It says, the following data was obtained from a survey of 20 children in a school sports team. Each height. The following data from a survey of heights. So these are heights. That's continuous data. Height is continuous. So we know it's continuous data. So, okay, now we have continuous data. Now let's go ahead. Each height was measured to the nearest centimeter. So here's another piece of important information. So now look at what it's saying. Here's our data: 136, 133, 136, 120, 138, blah, 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 blah. So now each height was measured to the nearest centimeter, because the truth is, this is continuous. So we never really know the value because it keeps going. But here we have rounded off. We have rounded our data to the nearest centimeter. Never forget that. We have rounded to the nearest centimeter, but it's still continuous, okay? Although we've rounded it off. So now, what we are going to do is, here they've said no commandment, but we just want to make a frequency distribution for this type of data, for continuous data, okay? Things that we have, height is continuous. We know that, we've talked about it. Now we want to look at it in a question. So basically we want to see how we make the table, because frequency distribution is a table. Oh, great. How are we going to do that? First of all, we're going to look for the smallest and the biggest values. Then we have an idea. So here's my smallest, 120. Okay, fine. And then here's my biggest, is going to be 144. All right, so my biggest is 120, is 144. Fine, it's fine again. So what I'm going to do now is I'm going to I'm going to make up my columns, right? Remember that one of the column would be height, and then the other column would be frequency, right? Frequency. So basically that's what it is. So am I going to say 120 like I was doing for discrete, to say, okay, the height would be 120, then I see how many 120s are there, I go to 121 or 122. No, I'm not going to do that, because this is continuous. I'm instead going to put it as a range. So first, I'm going to say, what number can I have that can go into 120 and 144? I can see it's like 4. 4 can go into both, right? Okay, so basically what I'm going to do is, I'm going to say, because 4 can go into 144, you can try it out, and 4 can go into 120. So I'm going to separate my things using 4. So I'm going to have 120 to 124. Then 125 is the next one. But the first, look, I want you to first write with a pencil. The first thing you're going to do is to write with a pencil. It'll be 120 to 124. Then 124 to 125. 125 to 129, then 130 to 134, then 135 to 139, then 140 to 144. So here's our data. Great. So here, frequency, that's what we have. Now we can start to put as a frequency. We've put in as our range. Now we can start to put as a frequency. But first of all, we're done. We are not yet. Now what I want you to know is, we always look at what we have rounded off to the nearest. Because remember that we said continuous data comes from measurements. These are measurements. Now, what we know is a human being can never be perfect. A human being can never be accurate. There is always a chance for error. And because of that, we have a topic that you probably did in IGCSE maths called bounds. We look at the lower bound and the upper bound for something. That's what I'm about to remind you. So what we're going to do is look for the lower bound and the upper bound for information, because human beings are never accurate. So when you see them say, oh, I've measured and I get 120 to the nearest centimeter, we're never going to take it like that. We know that it could have been smaller, it could have been bigger. So what we do is we use bounds. We see, what did you round off to the nearest? To the nearest centimeter, which means to the nearest 1 centimeter. So what you do is you divide by 2 and you get 0.5 centimeters. Now, what we then do is, when we get the 0.5, we are going to know that this value is actually, if they give us 120, it should be between, we remove 0.5 from 120, we'll get 119.5. And then if we add, we'll get 120.5. So we know that it is actually between 119.5 and 120.5. That's how we do it. Okay, great. Now, when we are doing it like when we've made up our ranges like this, what we simply do, because what we want to find is the intervals, we're going to need them, as you see, when we are going to be calculating things later on. But what we're going to have to do is to make our boundaries correct. Okay, we need our interval boundaries or the class boundaries. We need to know what the boundaries are. Now, these are not yet the boundaries. When we have it like 120 and 124, no, we are not yet. Because we remember we have measured to the nearest centimeter, so we need to include that. So what we're going to do is we go to the smallest number in here, we subtract that 0.5, and then we go to the bigger one we added. So if I subtract from this, okay, what am I going to end up having? I'm going to end up having in my height, okay, I'm going to end up having, if you want to put two columns, that's up to you. You could now have it to say then the height, then my frequency, right? Then my frequency. Now I'll still say, what would be my height? Well, my height is going to be, now what I want you again to know before I go ahead is, you see writing 120 to 124, we can even write it like this to say height, then in centimeters again, we know it's in centimeters, I should put centimeters, then frequency, right? We can write it to say, I'm going from 120 to 124. So I'm going to use the symbol H for height. I would say 120 less than or equal to height, which is less than or equal to 124. That means 120 to 124. Then 125 to 129, I'll say 125 less than or equal to height, which is less than or equal to 129. That's another way of writing, and I can be able to put my values. Now, what I'm going to do is, what I want you to know is what I'm going to do. One more thing before I start putting the frequencies and finding out the things, I should now include my rounding off. So yes, now I'm going to include it. So what's going to be my height? Instead of 120 to 124, it's going to be minus 0.5. It becomes 119.5. 2, if I add 125, add 0.5, it becomes 124.5. Now, what is the next one? 125, I subtract. Remember to remove. This is at the left, so I subtract. Now, I'll give you a tip. The one at the left, you just keep imitating the one on the right in the previous one. But you can subtract. To say 125 minus 0.5, you get 124.5, right? So now what I want you to know, I'm going to use not this way. We actually use this one to say 119.5 less than or equal to height, but it is less than 124.5. Then 124.5 less than or equal to height. We put less than or equal to on the left, but it is just less than this one on the right, which is going to be 129.5. Okay, to be 129.5. We remember to edit. Now here from 130 we remove, we'll get 129.5, which is less than or equal to height. Then on 134 we edit, it will be 134.5. Then from 135 we remove, it will be 134.5 less than or equal to height, which is less than 139.5. We increase on the right. Remember that. On the left we reduce, it becomes 139.5 less than or equal to height. You can do it with a calculator, right? You can do it with a calculator, which is less than, yeah, it'll be 144.5. Okay, we add on the left. Remember that. Now we have put our thing. So great. So now what we, so now what we are going to do is, I want to move it a bit so that I have more space. Okay, so now what we are going to do is to now put the frequency. We are done. This is our table. These are now boundaries. What we had before was we didn't have boundaries. Those are not yet boundaries. But now once we have done this, we now have our boundaries. Now, after rounding off, you've done amazing. Well done. So now let's put our values. Let's go and find out things. Let's go and find our values. Anyway, we can find it out. Let's go and put. So first I'm going to see values that are starting at 119.5 but should be less than 124.5. They are greater than or equal to 119.5 but should be less than 124.5. I go and see my values. So 119 to 124.5. Don't forget that. Okay, but they should be less than 124.5. So 120 is one of them. It's just greater than 119 but less than 124.5. Then on this road, 138 is out. These ones are out. I go to the last one, it's out. 130, 131 out. 124 no, 125 is bigger than that, so it's out. 144 out. Okay, so it's only one thing. So here I know that there is only one thing. Okay, right. Now let's go to 124.5 124.5 to 129.5. So it should be greater than or equal to 124.5, but less than 129.5. Let's see. 133 is out. 138 is out. 133 is out. 131 is out. Because it's greater than 124, but less than 129.5. There we go. 127 fits. Another 127 fits. We now have 2. So we keep going. 131, 125. It fits. Okay, it's greater than 124 but less than 129. 128 fits again. So now we have 4 things, and 129 itself, okay, it is less than 129.5. So at the end of the day, we have 5 things. So we can go ahead and put 5. Now I'm going to use one crayon. Remember to be careful when you're doing this. They should now be between greater than or equal to 129.5. But less than 134.5. So Grace, basically we can go ahead and do that. If you're having some trouble doing it, then I can give you a tip. You can use your initial ranges if you're having problem with the one that's rounded off. It's still going to give you the same answer. So now I can say I want from 130 to 134. It's the same as this third one. Trust me, believe me, I'll give you the same. So if we want from 130 to 134, let's find 133 is 1, 2 here, 131, 3, okay, 4, 5, 6, okay, 6 is to 134, right? 7, so we have 7. Can you see that? These ones that I've slashed in white, okay, 130, then 5, 4, 5, 6, and 7, 130. So we have 7 of them. Okay, now we can go to the next one. It will be 135 to 139. So remember this, you can just rub with a pencil at the end of the day, okay, because this is not part of your stuff. But this was the initial table that helped you then make the final one. Okay, great. So now from 135 to 139, okay, 136 is one of them. 2 here, to 139, we have 2 so far. 135 here, 3. 137, 4. So we have 4 of them. We have 4 of them. Then 140 to 144 is our next stop. So let's go 140 to 144. 141 is one of them. 143 is 2 now. Here, 3. So we have 3 of them. So it becomes 3. And this is what your frequency distribution looks like. You've done amazing. You can put the total and you'll be able to find the thing. Now, okay, you can put the total and you can be able to find, you say 1 plus 5 is 6, plus 7 is 13, plus 4 is 17, plus 3 is 20. So our total, you can have your total is 20. Okay, and you're done. Now, something I want you to know is, why did we do all this? When you have done it like this, now when you have boundaries, remember that these are now the boundaries. We should be able to round off. Before we do those, we should be able to find the bounds before we do the boundaries. Now we have our boundaries. Now we can be able to find what we call the interval width, because we're going to need it. You're going to see that. Now, how do you find the width? Okay, so what we should be able to find, the reason we've done this, we should be able to find the interval width again, because there are times when we are going to need information from these tables. Now, interval width is just going to be upper boundary, okay, upper boundary minus the lower boundary, okay? For anyone, you can choose for anything, you find the same answer. So basically I can use the last one, 139.5 and 144.5. So it'll be 144.5 minus 139.5. And I'm going to get 5. This is correct. But if I had used this first, I would say 144 minus 140, I would get 4, which is wrong. So be careful there. Be careful. I've told you. Okay? And that's what you had to know for this one. You had to round off. Don't ever forget that. And you should be done. Bye for now. See you in the next video.